Hey, what is up, guys? This is Sunday afternoon video, and this is the related, not so related, MacBook Pro Microsoft Surface 4 video. As you know, if you don't know, as you've been following me on YouTube, you know that I've been working with some Microsoft Surface tablets. I've been struggling with trying to find the faults on the circuit board. This board itself, I can't even get the little LED to light up when I plug it into the charger. It's going to be like some famous last words right here. So this plugs in both ways. It's like an iPhone charger. And if it works properly, it should light up. So there's that one. Oh. And this is actually the original tablet I was trying to fix for this guy. So glad he backed everything up on it. So you plug that one in. That in there. Ah. See a little LED? You can see that. It lights up. So, and it's not connected to the battery, so the batteries, you can take that out of the equation. You can tell it works both ways. Lights up. LED on both sides. Thank you, Microsoft. So, with that, so that's a first issue with this board right here. And they're the same exact boards. They're 4 gigs, I want to say i5 or i3 processor. Minus the difference in the PCB color. They're pretty much, like I'd say, 99% the same board. So, the related part to the MacBook and the Surface tablet, right? How are these guys related? Other than that, they're both they're PCBs and they have an array of components attached to this PCB. Is that I am like 99% certain that these are capacitors right here. And as I've been going to YouTube University, capacitors should not show, when you test this with the multimeter, you shouldn't see, and you put it on continuity mode, you should not have continuity from this side to that side. But when you test a capacitor, one side should show continuity to a common ground. So that's ground, that's ground. Pretty much any copper you see on this PCB, like that guy, that guy, that guy, because I believe that copper is underneath this green silkscreen material, if you will. And that's how they mask off. You have like a copper sheet and then they mask it off. And then that's how you get your traces from your quote-unquote wires, if you will, if you're breadboarding. So, those being capacitors, I'm going to do this quote-unquote live and see if this is the case. So, now we're going to bring this back to the MacBook, trust me. Got that. So you can see my multimeter here. There. The little kickstand on the back is not the best, so sorry about that. You can't see it. So it's an OL diode mode, and you got that continuity mode. Just kind of listen for the beeps if the multimeter's not in frame on the video. That right? So every time I've seen a capacitor on a printed circuit board, it's brown, and as I've said in prior videos, if it's a resistor, it'll be black. So you can see the brown color and the black colors visually distinctive in there. And then bonus tip, if you see a diode, usually there's a gray bar. That would be, I'm like 99% sure that's a diode because it's got that little gray bar right there. So just doing continuity check, you can tell that all the ground should be connected to the ground, common ground. Boom. Ah. Nope. Nope. Ground. 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 Let's see if this is ground. That copper, that's ground. That's ground. Oh, I like that. Yeah. That connection on my part. Ground, ground. So you get the idea. All these screw holes are grounded out. So, you know, I guess the idea is you don't create a short. So I think this capacitor right here, I don't know if you can see that. There's a brown guy. Capacitor right there. See how that multimeter went? That's like, I don't know why it exactly does that, but when you do that, there's like a continuity for a second, and then it's like the capacitor kicks in. So one of these sides of this capacitor is going to be grounded out. That's just the way I understand that all these capacitors will be connected, interconnected on the circuit board. That one side of the capacitor, if you know of like a traditional cylindrical capacitor, there's a little gray mark on it, and they're usually black. The gray mark denotes the negative side because that's the shorter of the pin on a through-hole capacitor as opposed to a surface mount. Same applies to this guy. It's just a surface. It's just a different package. So this side on the top, if you will, this is the batteries down here. The top side right there, I believe is ground. So if I do that, and it doesn't matter which probe you do it because we're just doing continuity tests on the capacitor. Ground. See how I did that? Same thing. So it lets me know that that guy is ground right there. And that guy right there is damn near the same color as that right there. So that would lead me to believe that that's a capacitor, that's a capacitor, those are capacitors. And this whole array of jazz right here is a capacitor, those are capacitors. So, knowing that that's our common ground, capacitor, capacitor. And I get that same, so only one side of these should be grounded out, but they're both grounded out. So if you test a capacitor, and what I understand if a capacitor is bad on a logic board, they show continuity through. You see how it was like, it clicked out for a second, and then it blew, if you will. See? Unless there's the circuit of these capacitors is different, that might as well, could be, you should not read continuity through these capacitors. And I'm not 100% sure that these are capacitors, but I do know in all my 40 years of doing PCB work that processors are generally have an array or an assortment of capacitors surrounding them. And that's where we segue back into the MacBook right there. Ah! That guy right there. And the cat wants to leave for a second. Ah! You want to be in the video? Oh, maybe. Okay. So, MacBook Pro. I'm eventually going to apply liquid metal to my MacBook because the internal screen's broken and I've been outputting to an external monitor using the NVIDIA guy through a display port. Watching a YouTube video, it's about 145 degrees Fahrenheit, just playing a YouTube video, and the fans are spinning anywhere between 3,500 to 4,000 RPMs. That's a little too much. When I was using internal display, I was doing about 120 Fahrenheit, so I kind of want to get it back down, and I'm hoping that putting some liquid metal on these guys will kind of absolve that problem or kind of bring down the temperatures a little bit. I bought this Cool Master, I believe, liquid metal, and it does not take much if you've watched any videos of liquid metal on YouTube. So, got a little sidetrack there. Processors. This guy, obviously the CPU of this guy, I'm going to assume that's the integrated GPU, the GM3000 or whatever it's called, and then that's my discrete GPU, the NVIDIA, the Kepler. I want to say all these guys on these wafers or this PCB, I guess you could say it's a PCB attached to a PCB, there is an array, again, an array of little components surrounding this. If I'm a betting man, I'm going to say those are capacitors. I don't know about the GPU, but I want to say that those might be capacitors on there. What these capacitors do in relation to the CPU, I have absolutely no idea, but I do know how to check for a capacitor on a logic board, PCB. And like these guys, big old boys over here, I want to say that those are capacitors too. So obviously my battery's unplugged. Don't want to test stuff like that. I don't think you want it when it's plugged in. So let's find a common ground on this guy. Copper on that logic board. Copper. I'm gonna assume that's a common ground. That's one of the big old boy capacitors over there. Both sides are connected through. Ah, see? Stop. Ground's on the left. There. Nothing on that side of that capacitor. Let's try this other guy over here. Yep, see? So, going over to the CPU, and then, I know you can't see this, but I'm looking at the little components on the CPU, and they're kind of the brown tan guys, and not like little, man, I don't even see resistors on this thing anymore. Like, I really don't. So, let's try this side. And then let's try that side. Ooh. So that's me actually testing both sides of those little components by this on the same PCB as the CPU. So maybe those aren't capacitors. Or somehow, see, that was me testing the NVIDIA GPU, and I was testing one of the little guys on the same PCB as the NVIDIA GPU. That's the bottom side of one of these little guys popping up. Top side. So there is a capacitor surrounding the NVIDIA GPU. Boom. Let me try over here. But the Intel is different, and then this guy, the Surface tablet's Intel 2. So I was getting the same results where I was showing continuity on both sides as these guys. Resistors? I don't know. Capacitors? Maybe. I don't think so. So my hypothesis of these being blown is probably not a good hypothesis, because I only got 2 of these boards and I'm getting the same results, but I did have my MacBook, and I know my MacBook works. And then same tan guys right there is that's on my PCB of my MacBook. On the PCB of this, testing those guys, tested continuity on both sides of that. I don't know if that's because the battery is disconnected and these capacitors do something when the batteries they're getting voltage in, but same results. So now that I'm thinking about this, these guys might not be blown. And if I betting man that this LED is not lighting up and I plug in that connector right there, it's going to be something in this power circuit. What kind of power circuit that is, I have no idea. I'm going to have to take another class at YouTube U, but kind of go from there. So that's kind of the gist of the related but unso related MacBook Microsoft Surface. And from here, I'm going to apply liquid metal to there. Cut that. That'll be a separate video. Liquid metal. MacBook. I'll spare you the board on how to take this thing apart. It's not that bad. It's actually really nice. Doesn't take too many screws. You pull that guy off. It's your CPU, GPU. And nice right there. You don't have to pull out. Thank God they're on this side of the logic board and not on the other side, because that would just suck. And then you got your little guys. You don't even really have to pull these guys all the way out. Remove all the thermal paste, obviously, with a Qtip and isopropyl alcohol or whatever you use. There were these little things on top of each, and there's an annoying little adhesive that these things were. I guess this is some sort of, I have no idea what these are, heat reflectors, or it's definitely not capped on tape though. So, like on the Intel CPU thing, you know, if you just have an old laptop like I do, this thing's 6 years old, will be 6 years old this year. Probably about 6 years old right now. We're in late part of 2019. You can kind of get your tweezers in there, kind of jam it up there, and all you gotta do is get one edge up, like that. And then when you get that edge up, you can just use your tweezers and gradually pull that off, separate that from the PCB of your, this is like a PCB, if you will. It's a little independent PCB, because you can just tell the color differentiation from the Apple logic board. Pull that up. Then I use my fancy dancy fingernail tool. Just gonna scrape the glue off. And kind of a back and forth motion in combination with some isopropyl alcohol on a Q-tip. And just, it took a minute, and then I got this little, because there's like hot glue residue, if you will, some sort of glue adhesive, and you can kind of still see it right there, and I'm touching it and it's still tacky with my finger. But I got all that off and all that off. And the idea of getting all that off and taking these off is that when I apply the liquid metal on the actual dies of the chips, is that the liquid metal is conductive because it is liquid metal. So like, God forbid some that were to fall off and then complete a circuit between two of these guys, or create a short, could render my computer inoperable. So back to YouTube U, there's a guy that was using this, and he put it around the die, and what this does is kind of creates an insulation barrier to where that liquid metal were to run off from your die, it would hopefully protect you from creating a short. And you literally just apply that. I don't know where my black light flashlight is, and you can tell this stuff's pretty cool because it's responsive to ultraviolet light after you apply it, and you can actually see it. It'll be like a purplish pink color, I guess, when it's dried. You can validate that with the ultraviolet light, like a little flashlight. I bought a little handheld black light from Harbor Freight for like $8. This you have to kind of order. So you do that, you apply those around the die, and then literally the same guy that on YouTube that talked about that also talked about applying the liquid metal. This stuff comes out super quick, like that. And you literally pop that out and then pull it back in, get a Q-tip and just kind of work it in there, wax on, wax off kind of thing. Do that. Because the first time I tried this, I squirted it and it was just everywhere. It was bad. So you apply those to both the dies after your stuff is applied, and you can put a little Scotch tape on there, mask off that, and then apply some liquid metal there, sandwich that together, and you're good. As you saw in the other video, YouTube video that I have unlisted, I took the wife's computer apart and applied liquid metal to her, I don't know, 10-year-old laptop, and it dramatically improved, and the fans aren't kicking on all the time. So yeah, go cut. This will be the raw video again, just ranting. When I was working with Q-tips and you get something like that, if you're not afraid of getting your fingers dirty, you can pull that off like that. And if it's kind of been doused in alcohol or whatever, it separates a little bit more fluid, no pun in there. You can pull that off, and then you almost have like a brand new Q-tip, so you're not going through a whole box of Q-tips cleaning this stuff. You just grab your snips. If it's kind of wet with isopropyl alcohol, you can cut that off, and then you can reuse the same Q-tip. So something I found out there. So there's your Sunday afternoon rant. Go Cowboys.